chapter 1 dealt with the collection of data. Well, once we collect data, we obtain it in what's called the raw form. So we call the data raw data. When you have raw data, the next thing that you would like to do is put the data in some sort of a manageable form. This is the organization part of the definition of the process of statistics. We're going to first learn how to organize qualitative data, and next we'll learn how to organize quantitative data. So again, when data is collected from a survey or a designed experiment, they must be organized into manageable form. Data that is not organized is referred to as raw data. Here are some of the ways that we can organize raw data. We could form tables, we could form graphs, and we could obtain numerical summaries. We're going to learn how to do numerical summaries in chapter 3. A frequency distribution lists the number of occurrences for each category of data. So our first example is going to deal with organizing qualitative data into a frequency distribution. The table that you're about to see lists the presidents of the United States along with their state of birth. We want to construct a frequency distribution of the state of birth. So this is our raw data. We have in this column the president, and in this column the state of birth. President, state of birth, president, state of birth. So for example, George Washington was born in the state of Virginia. Abraham Lincoln was born in the state of Kentucky, and so on. Now to organize the data, basically all we do is we go down the list of state of birth, and as we encounter a state, we list it and then put a tally. So George Washington was born in Virginia, you put a tally next to Virginia. John Adams was born in Massachusetts, so you write down Massachusetts and put down a tally for Massachusetts. Jefferson was born in Virginia, so since we already have Virginia in the list, we just put a second tally for Virginia. Once you've exhausted the list of raw data, you then go ahead and sum up your tallies in a frequency column. So Virginia had 9 presidents born within that state. Massachusetts had 4 presidents born within that state. A quick perusal down the frequency columns leads you to the conclusion that Virginia is the state that had the most presidents born within it. Now what we're going to do is construct a relative frequency distribution. The relative frequency is the proportion or percent of observations within a category and is found using the formula relative frequency equals the frequency of the category divided by the sum of all the frequencies. A relative frequency distribution lists the relative frequency of each category of data. Now in the last example, we constructed a frequency distribution for state of birth. Now what we're going to do is construct a relative frequency distribution of the president's birthplace. Recall that we, in the last example, listed the state and the frequency. To obtain the relative frequency, the first thing that we need to do is add up all of our frequencies. So we take 9 plus 4 plus 1 plus 4 and so on, and we obtain a sum of 43. Now this result shouldn't be surprising since we've had 43 presidents of the United States. Then you take each frequency and divide it by 43. So for Virginia, we're going to take 9 divided by 43, and we get about 0.2093. For Massachusetts, we're going to take 4 divided by 43, and we get 0.0930. Continue doing this for the remaining states, and you have your relative frequency distribution. Now, it's a good idea to verify that you didn't make any errors in computation by adding up all the relative frequency distributions. If you didn't make any mistakes, the sum of all the relative frequencies should add to 1. Of course, there might be a little bit of rounding error, so you might get 0.9999, or you might get 1.0001, but the sum nonetheless should be extremely close to 1, taking into account rounding error. Expression, a picture is worth 1,000 words, and the same holds for statistics. We learn how to summarize raw data into tables but oftentimes it's hard to get a good visualization of what the table is trying to say. So to address that concern, we have ways of graphically representing data as well. We graphically represent qualitative data in one of two ways. The first way is through something called a bar graph. A bar graph is constructed by labeling each category of data on a horizontal axis and the frequency or relative frequency of the category on the vertical axis. A rectangle of equal width is drawn for each category whose height is equal to the category's frequency or relative frequency. So what we're going to do is draw a bar graph, a frequency and relative frequency bar graph for the president's birth state data. So here's how this operates. For each category of data, in this case state of birth, we label each state on the horizontal axis. So Virginia, Massachusetts, South Carolina, etc. Then we draw a vertical axis for frequency 0, 1, 2, 3, etc. And then you recall that in the frequency table, the state of Virginia had 9 presidents born within it. So we take a bar and draw up until we reach a frequency of 9 for the state of Virginia. For the state of Massachusetts, we take a bar whose width is the same as the state of Virginia and draw a vertical bar up until we reach 4. Continue doing this for the remaining states within our frequency distribution. One thing to remember is you always want to have a title for every graph that you draw. You want to have your horizontal axis labeled, in this case is state, and you want to make sure your vertical axis is appropriate labeled, in this case frequency. Here's a relative frequency distribution for the same data. You'll notice that the shape of the graph looks exactly the same. The only real difference between the two graphs is that the vertical axis is now relative frequency. So the height of each bar corresponds to the relative frequency of the category of data rather than the frequency.
Data in the following table represent the educational attainment in 1990 and 2003 of adults 25 years and older who are residents of the United States. The data are in thousands. We are to draw a side-by-side frequency bar graph of the data and then answer the question, are more Americans earning bachelor's degrees? Since in constructing a side-by-side bar graph, we use relative frequencies, the first thing that we need to do is to calculate the relative frequencies for each one of the different educational attainments. We do this for both years, 1990 and 2003. Remember that we do this by dividing the frequency by the total for each column. This is our side-by-side frequency bar graph. Notice the educational attainment along the x-axis. Along the vertical axis or the y-axis, we have the relative frequencies that we calculated in the previous table. The purple stands for the frequencies, relative frequencies for those persons getting their education in 1990, while the pink refers to 2003. And to answer the questions, are more Americans earning bachelor's degrees? The answer would be yes. For bachelor's degrees, we see that the bar for 2003 is higher than the bar for 1990. A pie chart provides a convenient way to present qualitative data graphically. It is a circular graph that has been divided into sectors. Each sector represents a category of data. The area of each sector is proportional to the frequency of the category. They can be created only if all the categories of the variable under consideration are represented in the graph. Bar graphs are useful when comparing the different parts, but pie charts are useful when comparing the parts to the whole. Let's look at an example where we construct a pie chart. The data presented in the last problem represent the educational attainment of residents of the U.S. 25 years or older in 2003 based upon data obtained from the U.S. Census Bureau. construct a pie chart of the data. What we do first is we calculate our relative frequency column. Remember that relative frequency, again, is the ratio between frequency of each category and the total for the column. We do this because we have to know the degree measure of each sector before we construct our pie chart. So we multiply each relative frequency for each category by 360, since there's 360 degrees in a circle. And this gives us the degree measure of each sector. Once we've done that, we mark off each sector and label it, in this case, with the education for each category.